Hello everyone, my name is Fatih Topak. I am a PhD student in Building Science program of Department of Architecture in Middle East Technical University, and I'm working with Koray Pekeriçli. Today I will be presenting you our research which is titled Towards Using Human-Computer Interaction Research for Advancing Intelligent Built Environments, a review. And here is my outline. First of all, I will start with an introduction to the topic. Then I will talk briefly about human-building interactions in conventional built environments. And I will explain transformation in the building interface. Then I will present you some insights derived from human-computer interaction research, and I will finish my presentation with some conclusive remarks. As we all know, building industry has the largest share in world's overall energy consumption, which constitutes about 40% worldwide. And as a result, buildings contribute to the carbon dioxide emissions released in the atmosphere with a share nearly of 50%, and this creates an enhanced greenhouse effect throughout their life cycles. As environmental concerns over the growing impact of buildings have become a critical level, there appear new improvement necessities for the built environment. And in recent years, with the purpose of lessening negative effects of buildings on the environment, there's an immense effort to integrate technological advancement in sensing, actuation, and automation systems to buildings. These tools include automated window blinds, smart thermostats, building automation, occupancy sensors, and Internet of Things products. On the other hand, people must spend about 90% of their times inside the buildings, in homes, school, or office, being busy with different kinds of activities. And regardless of any concerns or arguments, buildings should still ensure their roles as human habitations to the full extent, because delivering high value to people through providing a comfortable and healthy indoor space is fundamental objective of any building. At the beginning of this research, we have taken three facts as the main drivers to carry out this study. The first one is that conventional built environments enable their occupants to regulate indoor environmental conditions like temperature, lighting, or air quality through interacting with simple physical interfaces like switches or thermostats. And human building interactions are multi-layered, complex, and influence both occupants and the buildings. Occupants are affected in terms of thermal comfort and visual comforts, and buildings are affected in terms of energy consumption, basically. And everyday interactive experience of people are increasingly enriched by technology, and a radical transition in the way people interact with the built environment is expected. In this respect, we decided to review the research methods that are used in human-computer interaction research field to envision human-centric solutions for new interaction modalities in the built environments. Before talking about transformation, it is important to have a glance at the current situation in our built environment. In this diagram, I tried to demonstrate interactions between people and buildings and their classifications. As you can see, apart from being adaptive or non-adaptive, interactions can also be classified as active influences or passive influences. Active influences are the ones that people take an action on building components to restore their comfort levels, including opening windows, adjusting thermostats, lowering blinds, turning lights on, and operation of plugins. On the other hand, passive influences are independent from the built space, such as adjusting clothing, drinking beverages, or being present in the spaces. After analyzing these classifications, I tried to relate the interactions with building systems performances. Blue lines shows the human actions that have an impact on HVAC systems, like opening windows, adjusting thermostats, lowering blinds, and being present. Yellow lines represents the interactions that affect the operation of lighting system. And finally, impacts on operation of electrical grid system is demonstrated by red lines. As you can observe, almost all human building interactions have an influence on the grid system performance, either directly or indirectly through other building systems. We have reviewed the impact of occupant actions on our buildings, but just as occupants affects their environment, the environment also affects occupants and their interactions with the specific contextual factors. And when we consider development in various technologies, including Internet of Things products, low-cost sensors, and automation systems in the recent years, we can all expect to have more intelligent buildings with some certain contextual differences in the near future. And resultantly, human experiences within the built environments will also be affected, and new ways of human-building interactions are expected to arise in intelligent buildings. When we look at the history of intelligent buildings, we can see that it improved parallel with the development in intelligent control of building operations after the 1980s. As you can see, it started with single-function dedicated systems and evolved into computer-integrated buildings in 2000s. And for the last 15 years, the integration level is accelerated with the evolution in computer, electronic, and information technologies, and the concept of intelligent buildings has been the key research subject in the field. If you compare a conventional building with an intelligent one, there will be some differences, of course. In conventional buildings, indoor environmental conditions, the operation of building systems and human-building interactions are independent from each other, although they all affect each other. In intelligent buildings, through the employment of integrated sensors and automation systems, these three will be interconnected. However, due to the contextual difference, the types of interaction possibilities that the intelligent buildings will provide is still not that clear. However, we believe that the next step of evolution will be the establishment of a common building interface that organizes and operates all building services and components based on data inputs from both occupants and environmental parameters, backed by the use of artificial intelligence, which perceives occupant-specific preferences and routines and supports human-centered building operation. However, it's fair to say that the research efforts in this field is still in its infancy period. So in order to build the research foundations on solid basis, we thought that it would be a good start to have a look at a well-established related research field, which is human-computer interaction. Human-computer interaction is an intermediary research domain, the overall aim of which is to discover insights about how people interact with technology. Most of the researchers that are studying human-computer interactions deal with balancing the human priorities and technological developments. We think that this expertise could be taken as a reference for being human-centered in the efforts of integrating technology to the human habitats. And there are various fields which the accumulated human-computer interaction research can contribute to building researchers, including interface design, development of interactive components, and directing human behaviors with interactive artifacts. So we have reviewed the research methods that are most frequently used by human-computer interaction researchers, and we came up with this table. Within the listed methods, we thought that ethnography and usability tests deserve further investigation since they are relatively unusual for building researchers. Ethnographic methods generally aims to examine the technology usage in residential, commercial, and educational settings. Building researchers can utilize this method for understanding human needs, behaviors, and actions in buildings, and sorting out the requirements for system integration of new technologies. On the other hand, usability tests generally used for developing and improving interface design in complex systems. Actually, there is a similarity in usability characteristics defined in human-computer interaction in architectural design. Accordingly, a triangle of user characteristics, task properties, and user interface in human-computer interaction research reflects itself in architectural design with a similar triangle of building occupant, building-specific tasks, and building interface. There are some research done by building researchers using usability testing, but it is still a largely undiscovered research field. So to conclude, the transformation in the built environment has been accelerated with the developments in artificial intelligence, Internet of Things concept, sensing, computing, and automation systems. And buildings of the future, which we call intelligent buildings, are expected to incorporate new forms of interactivity, and conventional touch input modalities will be subject to change. And although there are certain features of the built environments that are not considered in human-computer researchers naturally, the accumulated methodological knowledge in human-computer interaction has the potential to facilitate a simplified path for the built environment researchers. And lastly, more research is of course needed to discover various dimensions of building interactions in future buildings. Research efforts in this field is believed to be still in its infancy period. Here are my references. And thank you all for your attention.